Welcome everyone, and today we're going to be covering the OmniSwitch 6860, the OmniSwitch 6860E, and we're going to throw in a little bit on the OMNIVISTA 2500, and you'll see why shortly. But the first thing I wanted to do was to present to you how the 6860, which was launched in May of this year, how it fits into the overall portfolio. As you may know, Alcatel-Lucent Enterprise has a couple of solutions it takes to the market, and the one I'm showing you here is what we refer to as the converged campus network solution. You can see that the 6860 here, highlighted in red, is part of what we call the unified access layer of the network. So that could be at the network edge. It could be part of a small core in a network. The OMNIVISTA 2500, shown in the upper left of this particular chart, provides some additional features that are important given the capabilities of the 6860, and we'll be talking about those in a bit. So that is how the 6860 fits into the converged campus network solution, and as you can see, it's part of a much broader portfolio that deals with the wired edge as well as the wireless edge. The wired core, consisting of either, stackables or chassis-based solutions. The wireless solutions can be controlled or controllerless, and there's a wide range of products in the wide area networking domain as well. What's interesting about the 6860 and Alcatel-Lucent Enterprise Data Solutions in particular is that the products that you saw on the previous slide also show up in this slide, which is covering our data center switching solution. So the data center switching solution is a solution we brought to the market in 2012, and it won Best of Show at Interop in that year. It's a very highly scalable, low latency, low power, and highly scalable from a pod mesh design architecture. The 6860 can be used as a top of rack switch in this architecture, and it has GigE capabilities. That's complemented by the OmniSwitch 6900, which has 10 GigE capabilities in the same top of rack application. Again, the OMNIVISTA plays heavily into this solution. I think what's notable to reiterate, the same products are showing up in both the data center switching solution as well as the campus networking solution, and that brings tremendous benefits to users of the OmniSwitch product family because they only have to learn one set of CLI commands. There's one operating system throughout, and the switches, including the 6860, which is today's topic, are very flexible and can be used either in the campus networking environment or the data center switching environment. Okay, so let's investigate a little bit about why we're excited about the 6860 and what makes it a little bit different from the rest of the product line. I think one of the main things highlighted on this particular chart is the fact that the 6860 has an embedded ASIC in it. This embedded ASIC allows it to do wire rate application enforcement. Up to 100 different applications can be monitored and have traffic, shaping and traffic policy applied against them. So this is all done in real time. That's, I think, a critical thing to understand here. We're not talking about something that is simply advising the network administrator about what's running on the network. This is actual low-level, deep packet inspection, traffic enforcement of the various applications that are running on your network. And I think that is unique in the market with respect to a device that can be used at the network edge. It has, other capabilities. Chuck will be covering some of the technology differences and improvements that have been made in this latest generation. With support for things like SDN, that's very important with its support of OpenFlow. The fact that it can, support a full range of PoE+, I think is significant. And the fact that it supports virtual chassis, I think, is also something that is notable about the switch. But like I stated up front when we kicked off the call, the 6860 isn't the only product we launched back in May. We also launched the OmniSwitch 6860E. Now the E is pretty much the same as the 6860 with everything I've said with respect to its deep packet inspection, wire rate, application enforcement with a dedicated ASIC. But what the 6860E adds on top of all of that is a dedicated coprocessor. That coprocessor is being used in the initial release to do what we call application collection. So the idea of application collection is that it will give you visibility of up to 1,000 different independent applications on your network. That visibility, can be reported on. You can see how it changes over time, and the idea operationally is that you would use a 6860E to get a very detailed understanding of all of the applications running on your network, and then drill down to the top 100 applications that you're most concerned about, and then use the DPI capabilities in the dedicated ASIC to do traffic enforcement, traffic shaping, traffic prioritization of those particular 100 applications that you're concerned about. Many IT folks that we deal with, don't even have a full understanding of all the applications that are running on their network. They don't know what they don't know, in other words. And the capability of this coprocessor gives you that visibility that was unprecedented before. The other thing I think that's interesting and special about the 6860E as opposed to the 6860 is the fact that the first 4 ports of this platform are capable of providing what is called in the industry PoE++. So this is 60 watts of power over Ethernet capability, and that kind of power capability is starting to pop up in various applications. Notably things like small cell deployments for carriers. It's also something you see in high def PoE video cameras. So if you have an application that's highly dependent on high def video cameras, chances are that they may be looking for the kind of PoE support that the 6860 can provide. One other feature I didn't mention previously on the 6860, but it's shared by both the 60 and the 60E, is the fact that it supports Bluetooth. So from an IT perspective, that's a highly convenient feature. You don't have to carry around the correct cable to connect into the switches, a Bluetooth dongle, and you're able to actually do management of the switch wirelessly over Bluetooth. So I think that's the highlights of the 6860E. Now, there are some of you on the call who may be quite familiar with the Alcatel-Lucent enterprise data switching portfolio. So I thought it would be a good idea to talk a little bit about how does it fit in with the rest of the portfolio. So, working our way left to right on this chart, we have the 6250 and the 6450. These are layer 2 switches. They have some, basic layer 3 capability, but really their strength and their sweet spot is being deployed at the very edge of the network. In the 6250's case, providing 100 megabit connectivity to end users, and in the 6450 case, we're talking about gigabit capabilities to end users and 10 gig uplinks. So, there's no change there. The 6250 and 6450 are your go-to switches for a basic edge switch that can do, the full feature set of layer 2, as well as some very basic layer 3 capability. As you move to the right of this chart, you see the 6850E. Now, the 6850E is a product that we still sell, but ultimately over time we see the 6860 and 6860E replacing the 6850E over time. So, today the 6850E has been, or has historically been, the workhorse of the Alcatel-Lucent enterprise data portfolio, being used for an advanced edge device, being used for a compact core, being used as a basic top-of-rack switch. The 6860E and 6860 will be able to do all of those functions, all of those features. But I think a couple of contrasts are in order here. So first of all, the top line here, we're showing that the 6860's total throughput is almost twice that of the 6850E. Its stacking capability is doubled over 6850E. Its PoE budget is nearly double that of the 6850E. You can now run PoE Plus on every single port in a switch. Virtual chassis technology, something we introduced, with our larger chassis-based solution, the 10K, and then also picked up by the 6900, which has been a runaway hit as both a top-of-rack switch and a compact core. Has been emulated by the 6860. If you don't know about virtual chassis, it's a really great feature that provides simplicity for IT, resiliency, and a pay-as-you-grow kind of approach. If you have someone who's kind of used to a big iron chassis-based solution, there's actually a paper attached to this webinar that talks in more detail about the benefits of virtual chassis. Another important difference, I think, with the 6860 is, of course, its ability to do application discovery and DPI, analytics and enforcement of applications. It's the only switch in the portfolio that's able to do that. And then lastly, the last line on the far right of this chart talks about OpenFlow and RESTful APIs. OpenFlow will be arriving in all of our switches, via a software upgrade, but the 6860 has it today, and so constitutes the only edge switch you can buy today that has OpenFlow support, which is an important protocol for SDN deployments. Something not mentioned on this chart, but I think quite important, Chuck will probably talk about this in a little bit, is the fact that it supports shortest path bridging, SPB, which is an open standard that previously had been supported only in the 6900 and 10K switches. We're now moving it into the 6860 as well. Okay, so that's how the 6860 fits into the overall picture. If we take a look for a moment about the OMNIVISTA 2500. Now, the OMNIVISTA 2500 recently went to revision 4. Revision 4 of the OMNIVISTA 2500 was very important. And in the context of this 6860, what's very important about OMNIVISTA Release 4 is that it provides the brains of the operation when it comes to the application analytics, the control of the DPI capabilities, and the visibility of those 1,000 applications that the 6860E is capable of viewing. The 6860 and 68E, provide all of the hardware and the hard-working muscle to identify and enforce policy on these applications, but it's the OMNIVISTA 2500 that actually provides the detailed reporting, the visibility, the application of these policies. If you need to make a decision to change the behavior of an application in your network, you're going to be doing that at the OMNIVISTA 2500 level and pushing out those policies, those rules to the 6860s in your network. So, with the OMNIVISTA 2500, you're going to get that application visibility. You're going to be able to see, who your top application users are. You're going to be able to analyze the performance of these applications and take appropriate action using the capabilities built into the 6860. And what does that kind of control? What does that gain you as an IT staffer or an end user? Well, I've mentioned a couple of times the fact that the 6860 and OMNIVISTA 2500 working together are going to give you the visibility, right? Like I was saying earlier, so many IT departments don't really have a good handle on exactly what it is running in their network. And without visibility, you don't have the knowledge, and the visibility is the first thing that comes to play. With that visibility, now you can use the DPI engine of the 6860 to apply control over those applications. And what do we mean by control? I think the chart sums it up well. For instance, you could be reserving bandwidth for certain business critical applications. If in hospitals, I hear these kinds of comments a lot that they're worried about providing guest access to their visitors over their wireless network because they're afraid that someone is going to bring the network down with Netflix or something like that. They're going to be streaming all these videos, and doctors trying to use the network aren't going to be able to get the airtime they need and the throughput they need. But with reserving bandwidth, you can reserve bandwidth that's critical to business communications, to the operation of the business, and leave the leftovers for non-critical applications like, for instance, guest internet access. It doesn't just stop there. You can also provide very fine-grained controls like just lowering the priority of certain applications, and even if you're talking about business critical applications, some are more critical than others. Certain areas of your business may be more critical. Certain applications may be more critical as well. Your billing environment is probably more critical to the operation of your business than, say, your CRM environment. You want to be able to exercise that degree of control. Of course, you may find you have applications that you absolutely do not want on the network, be that for performance reasons, be that for compliance reasons, be that for legal reasons, and those you just want to absolutely blacklist. You want to keep them out of the network completely, and you'll be able to rest easier at night. If you're talking about real-time applications, jitter and latency are very, very important, and these are parameters that not only can you monitor with the visibility we talked about earlier, but you can also control through features like SIP fluency in our switches, being able to tell the difference between a SIP video session and a SIP audio session, and optimizing accordingly, I think is a very important attribute that you gain by using the tools provided to you by the OmniSwitch 6860 and the OMNIVISTA 2500. With that, what does it all mean, to the administrators of the network? What the picture looks like is you end up, being able to imagine an environment where, you're providing, many virtual performance characteristics, for your business. Blocking those that are not critical, providing the high priority to those, critical business real-time applications. Taking a look at your other business apps and assigning them perhaps a lower priority, and then personal use stuff. Well, that gets best effort, the lowest priority. And this is all happening. I think it's important to recognize at the network edge. This means that everything I'm talking about applies equally to the wired or the wireless network. And so, with a 6860 in the mix, you're able to have this kind of degree of control and, provide real value, to your user base and simplify the life of IT, moving forward. I think with that, I'll ask Chuck to take over the presentation from here on out. Chuck Bell is a solution architect for Alcatel-Lucent Enterprise and a guy very, very familiar with the technology behind the 6860. Over to you, Chuck.
Thanks, Rob. So Rob did a good job of sort of positioning the what. I'm going to talk a little bit about the how. And first I'm going to kind of start off with how the switch can be positioned in an overall network architecture design. And because of its capabilities, it can actually be positioned in several different ways. So the most common way is and Rob sort of alluded to it before, where we have a compact core. Maybe it's a pair of our 6900s or maybe a pair of chassis switches. And then you have sort of a two-tier design or architecture where the 6860 or virtual chassis or stack of 6860s would be positioned at that IDF closet or that access switch layer. Again, one of the most common type of deployment scenarios. Additionally, though, because, and I'll get into some of the nuances of the feature functionality of the box in a moment, but because of its capabilities and it has additional bandwidth capacity as well as different form factors, it could actually be positioned in the distribution tier of a 3-tier network. So the virtual chassis, again, functionality coming into play here, but here instead of having end users plug directly into the switch, we would actually have access closets plugging into the switch, and I'll show you what that form factor might look like in the next slide. And then, as Rob mentioned, one of the very unique capabilities of this switch that is very different from what other vendors are doing is it has the capability of participating in an Ethernet fabric. And although this particular webinar that we're giving today is not going to go into depth on SPB or Ethernet fabric technologies, this particular feature is inherent in the 6860. And what this allows you to do is this architecture on the far right, which is actually extending an Ethernet fabric, which typically is resident within a data center, and extending that all the way to the campus edge, to that access layer, and providing this kind of fabric architecture where you can extend services in a very simple and effective way. And because of the network analytics component and the deep packet inspection that Rob was referencing, that's part of the ASIC and the coprocessor on the 6860, this Ethernet fabric now becomes an intelligent fabric. But before I go into any more depth on that, I do want to cover sort of the highlights of the portfolio within the 6860 line. And if you're familiar with other OmniSwitch lines from Alcatel-Lucent Enterprise, we basically have several different flavors of the 6860 as well as other OmniSwitches. And so there will be 24-port models, 48-port models, 24 and 48-port powered models, and then, as I mentioned, that U24, which is a fiber-only model, which could be positioned in that distribution tier like we were talking about. Each of these models can be mixed and matched in a virtual chassis or a stack. So it doesn't necessarily matter that you have an E or a non-E or a 24-port or a 48-port powered. You can blend them to the needs of the particular closet or the needs of the particular architecture. I do want to, there's quite a bit of information on this chart, and you can pull down this data from some of the data sheets that are attached to this webinar. But a couple of things that I do want to highlight, and that is one that Rob had mentioned already, which is the power supplies. So the power supplies have been a little bit of a different architecture from what we had in the predecessor product, which was the 6850. And these new power supplies are load sharing and load balancing. So the previous product was more of a active standby scenario. So now, because of their load sharing, when you put multiple power supplies in the unit, you can get a full 30 watts per port on every port, say, for example, on a 30-port switch. And because they're so efficient, because they were designed with the same power supply architecture that our data center switches were designed on, we can actually get those a handful of ports up to 60 watts per port for things like pan-tilt zoom cameras and whatnot. The other feature that the 6860 and the differences between this product line and, say, previous product lines is there's an E-series and a non-E-series. And Rob started to talk a bit about that coprocessor. And I'm going to go into some details on the use cases of that coprocessor and the use cases of the network analytics engine that has been added to the E and the non-E. So just to clarify, the main difference between the two is the E-series does have a coprocessor, and the non-E series does not. But both products are capable of providing the network analytics in hardware at wire rate, like we had talked about before. And in a particular stack or a virtual chassis, when you were to put, say, for example, 3 or 4 switches together and manage them as one entity, you really only need one E-series switch in that stack to get the visibility component, and then the rest of them can be non-E. So when you're designing and architecting a particular network, you don't necessarily need an E-series for every element in a multi-stack virtual chassis. So the product itself, if we peel the onion back a little bit more and look at the details on on the actual hardware. Let's start at the back first, and those load-sharing power supplies. If you're familiar with our previous line of products, you'll know that the power supplies actually were physically attached to the back of the switch. These particular power supplies slide into the switch, and they're hot swappable. As I mentioned, they're load sharing and very, very efficient. Because of those new power supplies, you can, as you can see on the top portion of the picture here, we can get up to 48 ports of PoE+. And that's 30 watts per port on every port, so the PoE budget is, in upwards of 1,500 watts on the overall switch. Because we have that additional capacity, you can get a handful of ports on the first 4 ports actually are up to 60 watts capable. Now, this is a 48-port switch, and if you're familiar with some of our previous technologies, you might be familiar with a concept called combo ports. So combo ports are no longer used in the 6860, so we actually have, if you count it up, we have a 52-port switch. So 48 ports of 10, 100, 1000, and then 4 ports of uplink capability, and these are SFP plus uplinks. They're on the right-hand side of the switch in this picture. And these 4 ports are 10 gig and or 1 gig capable for either uplinks and or user connections that can be up to 10 gigabits in speed. So the other major difference between this product and how the stacking technology works. So number one, the stacking technology has changed from what we used to call a stack to a virtual chassis. And for all intents and purposes, it's basically the same thing. You manage up to 8 physical elements as one management domain, so one IP address basically to manage it. One is elected as the master, and the rest are backup units. The technology is called virtual chassis because it's aligned with our data center strategy with how we do virtual chassis within top-of-rack switches and core switches, utilizing the same code. But more importantly, the stacking cables, or the VFLs as we call them, virtual fabric link connectors, have been doubled in capacity. So now we can get 20 gigabits per port of backplane capacity, in essence, to interconnect these switches of anywhere from 1 to 8 units. Now, from a management perspective, several different ways to actually manage the box, and we talk about the EMP, or the Ethernet management port, on the bottom left. You'll see that icon there. That EMP port is only on the E series, and then the rest of the model switches, the non-E series, are usually managed from the front panel. And we have a micro USB console connector as well as a micro USB 232 connector. And that console connector actually is just a standard USB cable that would plug into your laptop or PC, and you can actually just load a driver and then actually manage that over USB. So you don't necessarily have to have the 232 adapters and things like that anymore, although we still support that with the micro USB connector on the bottom right. Additionally, as Rob had mentioned, there's a USB port, and we can actually support a Bluetooth dongle. So you can plug a Bluetooth dongle into that to actually manage the switch over the air via Bluetooth. The next thing I want to go over in a little more detail is this network analytics, as we had talked about before. And there's really 2 components to it. And the first component is that visibility component, or the APPMON is the actual feature, application monitoring. And this is the feature that requires the E-series switch. And why would you want to use, visibility in a network appliance, let's say, for example? This is not something new. I mean, we've been doing this in networks for many years. You think about the next generation firewalls that are out there from the likes of companies like Fortinet and Palo Alto, but typically they've been relegated to the perimeter or some choke point in the network, a wide area network connection, or in between the data center and the rest of the network. And that becomes a very expensive proposition because you have to build a very large next generation type firewall to be able to get that deep packet inspection visibility to support the amount of throughput that's coming into these choke points. So what we've done with the 6860 is we've been able to abstract that capability and push that out to the edge of the network. So in essence, now you have firewalling type visibility at layer 7 and below, all the way out at the ingress to the network, really where users are plugging into. And so the APPMON feature is a mechanism to collect that data to determine which applications are riding on it. And I'll get into a little more granular detail on exactly how it works in a moment. But it utilizes that coprocessor on the 6860E. And what we do is we analyze what's going on. We might burn it in for a few days or a few weeks and collect statistics on the network. And we utilize the OMNIVISTA platform to kind of present those statistics to you, as well as the OMNIVISTA platform to provision the signatures that it's looking for. So once we look at it for a period of time, then we can do something with it, and that's when we push the applications down into hardware to be able to control the data. So the way the APPMON works from a high-level functional view, if you think about how a packet ingresses and egresses a switch, on ingress, we'll take a copy of that packet, basically a port mirror, if you're familiar with port mirroring and how that works. We take a port mirror and we send a copy of that packet to the coprocessor. And the coprocessor has what's called a signature matching engine, and that's the licensing model that OMNIVISTA will download the signatures, push those signatures to each of the switches in the network, and then as the packets are being sent to this coprocessor, it's querying the signature matching engine. And if it has a hit, then it would send statistics not only to the OMNIVISTA, but also to the CLI. It's a little easier to view, of course, in a GUI. But anyways, we can see those statistics as to what applications are riding on the network. But it does not affect the pipeline, we'll say, as from an ingress to egress type of traffic flow for the data plane. So the packets are just copied and sent to the coprocessor for analysis, but the actual data still goes in one port and out of another port, just like a normal switch would from any other one of our products. Once we have the visibility component down and we say, okay, well, this particular branch office here is, maybe has a handful of applications. There's only a handful of critical applications. Maybe it's like HR, email, things of that nature. But because it's a branch office, they're using port 80. Maybe they're using HTTP. So really what does DPI do for you over, say, a standard QoS policy? So, of course, we can do standard quality of service or access control lists on all of our portfolios. So the 6860 takes it to another level and looks within the payload of that data and looks within the port 80 traffic and says, oh, by the way, yes, you're using a lot of port 80 traffic, but that port 80 traffic, that HTTP session, is the HR application, and that's business critical, but it's also people going to YouTube or people going to Netflix or something along those lines. So maybe you have a business policy and you recognize this now that this particular branch office is using certain applications on the network and you need to now do something with it. Now you can make a business decision that I'm going to rate limit or block or I'm going to prioritize the business critical application over everything else. And that's where the DPI, or the application enforcement engine, comes into play. And all of the products in the 6860 family support this, and this is done in hardware. And there's a couple of key concepts that I need to make you aware of, some new terminology that is part of the application and enforcement engine. And what it does is it uses the concept of a flow tracker or a flow table. And what a flow is a 5-tuple. And if you're familiar with source IP, destination IP, source MAC, destination MAC, and protocol number, that constitutes a flow. And maybe that's that end user accessing the HR system. So then what that flow does in the flow tracker table is goes against a signature. And these are the signatures we were talking about that OMNIVISTA would send down to the switch. And the way the signature works is the flow tracker, the flow table, will match against that signature matching engine. And if there's a hit, then it would query the access control mechanisms and or the quality of service mechanisms to do something with it. And that was that concept of maybe blocking or rate limiting certain types of traffic. As I mentioned, OMNIVISTA is the mechanism not necessarily required to for this feature to work, but required to sort of manage how the licenses are maintained, manage how the signatures are downloaded from the cloud, and manage how you get visibility and actually can push policy to the network. So they're very integral to the solution. So as I mentioned, this flow management and how the DPI engine actually works, the flow table, you can actually have up to 8,000 flows per switch. And that might sound like a lot, but in reality, it's actually not a lot. So you don't really want to position a 6860 in that distribution model like we were talking about, because you would have many closets, and you figure a typical session from a single user might be in the dozens, if not hundreds, of particular sessions per user. So, if you were to, it's not really meant to be that large firewall consolidation device at the perimeter of a network. That's not its intent. Its intent is truly at the edge on the ingress. But we can support up to 8,000 flows, and that's per switch. So if you had a stack of 8, it's 8 times 8 or 64,000 flows. So each of these flows are dynamic in nature. So meaning that they time out. So it's not like, if you have a particular flow, it's only for the lifetime of that flow, and then it can kind of time out and release the resources for other connectivity. And then the signature matching engine is just that. It's a text file that's pushed to the switch from OmniVista. It resides on the flash, and the flow tracker table queries that engine to see if they have any matches. And then the DPI manager or the QoS policy engine, all that is pretty much the same as it was in previous products and in other products, or if you were to use this as a standard switch, the access control lists and things of that nature. Alcatel-Lucent's OmniSwitch has a very comprehensive QoS and policy engine. When you compare it to other like switches, it actually exceeds those capabilities or their capabilities. So another high-level framework overview of how the DPI works. In a similar fashion, let's say, for example, this particular use case is a video flow from port A to port B in the OmniSwitch. So on ingress, we take a copy of that, not the port mirror copy that we send to a coprocessor, but this time we're actually doing it in hardware. And we take a copy of that and we establish that entry in the flow table based off of that 5-tuple. And then that flow table will query the signature matching engine, and if there's a hit, then it will query the operating system to say, hey, do you have a policy based on this match? And if we say, for example, the QoS, yes, we do have a match, we're going to put the video into the high priority queue so that it has the, we don't have any latency or jitter or things of that nature. And then, so the first packet might make it through that process because it kind of loops around there. But the second or third packet and beyond, once the flow has been established and it's an entry in the table, then the rest of the data that comes in after that will be prioritized. And it gets prioritized on the ingress filter. And then it would just egress the switch, go into the output queue for the high priority, and then egress the switch on port B. So that's functionally how the DPI engine works within the 6860. I've talked quite a bit about OmniVista, and for those of you who aren't familiar, OmniVista 2500 is our network management platform. In this particular context, we're utilizing OmniVista as a mechanism to do a few things with regard to network analytics and DPI and APPMON. So first and foremost, we use it as a licensing model, our licensing mechanism, so that these signatures, of course, new applications are written all the time in the industry. Dropbox today, it might be something else tomorrow. And what we can do is there's this licensing model where it pulls new signatures from the cloud. It pulls them down monthly as new signatures are written. And then it will push those signatures out to all the switches in the network. And there's no need to SSH into the switches or FTP, signature files onto the switches to maintain consistency. This is all done automatically through the use of OmniVista 2500. But more importantly, like we were talking about, when we're baking the network in and we're seeing all the applications that are riding on the network, we need to push a policy now. We need to say, okay, well, I want to deny Dropbox because that's my corporate policy that I'm not, we're not allowed to let users use that file sharing mechanism. So we can push a policy from OmniVista to all the switches in a one-touch type of scenario to block that type of application. And the same thing can go for if you want to prioritize an application and or rate limit an application. So the unified analytics and the use of application visibility for what OmniVista can do, again, is integral to how it works and makes the visibility of it very, very easy to see what's going on. As as we move forward, and as Rob had mentioned, this one of the key components to OMNIVISTA is how it's licensed. And the licensing model is a yearly renewal type of model. And so even though, it pulls the licenses down on a monthly basis and pushes them out, you have to sort of license OMNIVISTA to be allowed to do that. So that's an add-on license module. And the nice thing about that is that you now have a reason to go back to your customers sort of on a yearly basis and kind of touch base with them to renew that license and talk about, new opportunities or different things that might be going on in their environment, and maybe, a reason to, chat about some new technologies that we can offer. But for those customers that maybe want to just try it at first, the platform comes with like 16 teaser applications. And what I mean by that is you don't have to buy the license out of the chute. You can kind of play with it with these 16 teaser applications. And that comes sort of free with the OmniSwitch and with OMNIVISTA. And then once you determine, or your customer says, hey, this is cool technology, I would like to try this a little more, then it's just a simple license upgrade path on the OMNIVISTA server to license it. And how it's licensed is per node. So you get a 1-year license for X number of nodes for the unlimited amount of signatures that are in the cloud. Now, moving forward, OMNIVISTA 2500 has a lot of these capabilities that we focused on this webinar, which is basically the application fluency or the network analytics component. So not only the visibility, but the licensing, as well as the provisioning and the one-touch operation. But it also is becoming more of a policy manager. So when you think about those business, now the network management system is in line with how to enable business process. So, when you take, there's always a gap sometimes between the technical leadership in an organization and the management or the business leadership in an organization. And how can technology enable business process? And this is really what I believe OMNIVISTA brings to the table in this technology. Because now you can say, okay, we have a policy that says you're not allowed to view videos during work hours of Netflix, as an example, or you're not allowed to do file sharing with a certain type of application like Dropbox or things of that nature. So now that policy can now be enforced at a business level. So it becomes a policy manager for network services. Moving forward, though, a lot of these things that we talk about with policy and with analytics and where OMNIVISTA is actually going and where the industry is going when we talk about things like SDN or software-defined networking. So a lot of the challenges that software-defined networking is solving from an industry perspective, we're building those components into OMNIVISTA, but we're building it as a hybrid approach. So you don't have to kind of forklift and go from traditional networking to software-defined networking day one. You can use this hybrid approach to evolve to that. So it's still a standard element manager, does all the analytics like we talked about, and become a policy manager. But then moving forward, it has a northbound interface, so you can have plugins like OpenStack and RESTful APIs from a provisioning perspective. And it has southbound interfaces, as Rob mentioned earlier, about supporting OpenFlow on our entire portfolio. And OMNIVISTA can actually act like an SDN controller to actually provision that in the future. So in essence, you have a mechanism to evolve to software-defined networking, still doing your legacy things where necessary, and maybe doing this next generation of network architecture and moving forward in the future. So that's pretty much what I was going to cover today. I'm going to hand it back over to Rob. I'd be happy to answer any questions if they come up. And there's some links on the side of the webinar here that if you'd like to download for more information. But Rob, I'll just hand it back to you for now.
Thanks, Chuck. Great overview. So I just wanted to close the webinar with making note of a couple of assets that are out there for you to learn more and take some more time to get an in-depth understanding of not only the 6860 but the entire Alcatel-Lucent Enterprise networking portfolio. So we held a virtual event a few weeks ago. It's a series of very short webinars that you can download at your leisure. 10 minutes at a time. It covers the 6860. It covers our unified access strategy, wired and wireless, and OMNIVISTA 2500 as well. So do feel free to register for that and check out the content that's there. Another pretty new, avenue to get the word out and get the message out has been our podcasting channel. The link is available here on this slide as well as in the attachment section of this webinar. The podcast is, again, another way to listen to content that you may not have heard before, or you may have already heard, and gives you a chance to listen to it on those downtimes that you may have in between meetings or in the car on the way to your next call. So the podcast is frequently updated, and I encourage you to check it out. Lastly, this link is included on the attachments of this particular webinar, but the product page for the OmniSwitch 6860 is located at this URL. And the 6860, as I've mentioned, is part of the overall Alcatel-Lucent Enterprise data portfolio. You can check out that data portfolio at the link referred to here.